Matrix multiplication is one of those operations that looks scary at first sight. But here is the thing, without it, neural networks wouldn't even exist. And here is a surprising fact. Unlike normal multiplication, in matrices the order matters. A into B is not same as B into A. We will prove that later, but first let's break down how matrix multiplication actually works. So today we are going to break down matrix multiplication step by step, visually, numerically, and in Python. So you will never see it as a black box again. Welcome back to Decoding Complexities. I'm Pradeep. In the last video, we covered matrix basics, addition, and scalar multiplication. Now let's step into the real powerhouse, multiplying matrices. Why does it matter? Think of matrix multiplication as a way of combining information. Rows represent entities like users, and columns represent features like age, income, or ratings. When we multiply matrices, we are basically matching patterns between rows and columns to get new insights. The most important prerequisite for matrix multiplication is that the number of columns of the first matrix should be equal to the number of rows of the second matrix, and the resultant matrix would be of size rows of first matrix by columns of second matrix. Let's consider matrix A, which has 1, 2 in the first row and 3, 4 in second row, and matrix B, which has 5, 6 in first row, 7, 8 in second row. When we multiply matrix A with matrix B, we basically multiply the rows of matrix A with columns of matrix B, multiplying corresponding elements from first row of matrix A with first column of matrix B and sum up the outcome. The result will become the first element of the resultant matrix, that is, first element in the first column. Similarly, multiplying elements from first row of matrix A with second column of matrix B and sum up the outcome, the result will become the second element of the resultant matrix. Same applies for the second row as well. Multiplying corresponding elements from second row of matrix A with first column of matrix B will make the first element of second row, and same for the second row of matrix A and second column of matrix B, which gives us the result 19, 22 in the first row, 43, 50 in the second row. That's the matrix multiplication. Now, let's take a look at the Python example using NumPy. Create two 2 by 2 matrices A and B using np.array method and use numpy.dot method to multiply both the matrices. We can also multiply two matrices by calling the dot method from the first matrix and passing the second matrix as an argument. Order in which we multiply matrices is very important. That is, A into B is not equal to B into A. Here is the result of B into A, which is not same as A into B. Let's take another example by taking two matrices where first matrix A is of size 2 by 3 and second matrix B is of size 3 by 3. And then we multiply A and B and the resultant matrix would be of size 2 by 3. Trying to change the order of multiplication, that is multiplying B with A, result in an error. If you would like to take a look at the code, link for the Python notebook is present in the description. So why do we care about matrix multiplication? In graphics, it rotates and scales objects. In machine learning, every layer of neural networks is powered by multiplying a weight matrix with an input vector. It's the operation that transforms raw data into learned patterns. So here is my question for you. Do you find it easier to think about matrix multiplication as rows into columns or as a way to combine patterns? Drop your thoughts in the comments. I would love to hear how you make sense of it. If you like the video, subscribe so you don't miss our next video on the matrix transpose, a simple trick that unlocks some of the most powerful ideas in machine learning. Thank you for watching.